Hello there and welcome back to the channel. This is part 2 in a series of 3 videos looking at DJI flight modes, compass errors and the GPS system itself. If you haven't seen the first video, please go and take a look. In this one we are taking a look at the compass, so let's get on with it. The compass is one of the most important sensors on your aircraft, and it is how it knows what direction it needs to point in. If there is a problem with the compass, it will not be able to use this position hold and it will not be able to return home. Now there are some rules around the compass you need to understand. First of all, around calibration. The basic advice for the compass is when you first get your aircraft, I would recommend calibrating it out of the box. But after that, you do not need to calibrate it again unless you travel a large distance. Now, I would say that is a minimum of 100 to 200 miles. The Earth's magnetic field does change as you move around the globe, and if you calibrate it at one location, when you travel a very large distance, calibrating it again is what might be needed to make sure that it does have the correct magnetic data. However, this does not mean you need to calibrate the compass all the time when you are flying locally. There is no reason to recalibrate the compass again if you're flying at a location which is only a short distance away from where you calibrated it before. You will also notice that I have got not Mavic Air in brackets, and there is a specific reason for this. New models like the Mavic Air now have a lookup table that stores global compass information. So instead of you having to recalibrate it, it is able to look at the data on board and know that the magnetic shift should be this level here. I would still recommend calibrating the compass out of the box if you do get a new aircraft like a Mavic Air. However, from that point forward, unless DJI Go tells you to, there is no reason to calibrate it again. When you do calibrate your compass, one of the most important things is you must calibrate it as far away from any metal or smart devices as possible. A compass is a highly sensitive device, and any form of ferrous metal or smart devices will affect it. Do them at least 20 meters away, leave your phone on the floor and leave it all to one side, and make sure you've got no smart watches on your person. If you've got an Apple Watch, take it off and leave it over by your bag whilst you do the calibration. As mentioned, regular calibration is not required when flying in a same or similar location unless DJI Go warns you, and if it does warn you, I would actually not calibrate at that point because there's probably something else going on, and we'll take a look at that a little bit more now. Next, we're going to take a look at compass errors and why they happen, and specifically the things that the aircraft could do when you get one. In this first scenario, we are looking at a normal flight with no problems at all. On the left, you have your compass sensor output and the aircraft's IMU output. And what we're going to do is take off and point the aircraft north. And as you can see that the compass is showing north and the IMU is still showing that position as 0. As you rotate your aircraft in flight, say 90 degrees, your compass would see that as a shift to the east and your IMU would see a shift of 90 degrees. Because these two are aligned, the aircraft knows that it is actually rotated, the heading has changed, and it would remain in GPS mode as expected. This is what your aircraft would do in a normal flying situation. However, if you then moved to a more urban area, there are lots of things that you should be aware of. For instance, around here you've got metal railings on the right hand side, lots of metal buildings on the left hand side, so there are some visual dangers that could affect your compass. Alongside the ones you can see, there are also the ones you can't, and under the ground you can also have things like high power cables and rebar in concrete and underground structures. All of these things can have an effect on your compass, and whilst the location initially could look perfectly good, these hidden dangers could cause your aircraft to have a compass error. In this situation, you might start to see some problems on the ground before you even take off. Because of the heavy metal and the electrical cables, your compass sensor could start going haywire and your aircraft would see this. Because it's not able to get a stable reading, DJI Go would throw up a compass error and it could tell you to recalibrate the compass. At this point, doing a calibration is a very bad idea because it's not that there is an issue with the actual compass data, it's that the power cables and the metal is causing interference. If you were getting anything like this, the first thing I would suggest is move to a new location, somewhere where you know that there is no metal or power cables in the ground, but don't instantly jump to recalibrate if you are in a location like this, and have a think about actually what could be in the ground. Could it be the railings? Could it be some underground power cables? You could also in this scenario get DJI Go telling you everything is fine and it's safe to take off. However, what can then happen is this can change as you get in the air, and I'm going to explain why. If you look at the compass sensor, it's actually pointing east, although our aircraft is pointing north. And the reason for that is the metal on the ground is influencing the compass. It's not causing a fluctuation in the reading or such a large amount of interference that the aircraft can't get a good position. However, it has influenced the compass information and the aircraft now thinks it is pointing east. At this point, it will tell you it is safe to fly because this is the only reference the aircraft has to knowing which direction it's pointing. So at this point, it thinks it's pointing east, although it is actually pointing north. As you take off, the compass would begin to settle, and as you move further away from that metal in the ground, the compass would then actually begin to rotate back to north because it has moved away from the interference source and it's now getting a good reading. The problem with this is the aircraft can see that the IMU data below has not changed. So whilst the compass data has changed, the IMU remains the same. And the aircraft then begins to get a little bit confused because although the compass data has suggested the aircraft has rotated 90 degrees, the IMU data is saying it hasn't. At this point, it has no idea what the true reading is because it can no longer use the compass data as good data because it knows it has changed. This is when you may get magnetic field interference errors or your aircraft suddenly jump into ATTI after you've taken off. It is not because there is loads of metal or interference in the sky, it's because your compass direction and heading has shifted as the aircraft is taken off. You will usually find this happens between 3 and 10 meters from the ground. Because these aircraft only have compass sensors, it has no way of determining its real true direction, and its only option at this point is to discount the compass sensor altogether and shift down into the next available mode. Something else worth noting is even if your aircraft has dual compass sensors like the Mavic Pro and the Phantom 4 Pro, it doesn't actually make a difference because that metal source could have done the same amount of influence on both sensors. As you've taken off, both sensors have seen the change from east to north with no change in your IMU, therefore it can no longer rely on that magnetic data. When you are in this situation, your aircraft can then do something called TBE or toilet bowl effect. This is a phenomenon where it begins to do an orbit out of your control. So whilst you've taken your hands off the sticks, the aircraft could actually start to rotate by itself and start doing large circular orbits which get bigger and bigger as time goes on. This can sometimes show up with a compass error, however, it can also start doing it and say PGPS, everything is good. This is because the compass data, whilst isn't 100% correct, it's not enough for the aircraft to fully understand what's going on. At this point, there are a few things you can do, and if your aircraft does enter TBE, something I have found personally that works well is to do a few total rotation yaws and rotate the aircraft quickly left and quickly right in full 360 degree rotations and stop and see if it stops the TBE from happening. To wrap up on the compass, it is a sensor that is highly susceptible to magnetic interference. Metal in the ground will have a huge effect on it, and it's something to be very aware of. And this metal is not always in the kind of structures you think. Even normal pavements these days can have metal in the ground. So if you are somewhere and you suddenly get compass errors while on the ground, don't instantly jump to calibrate it, but look at the surface you're on and try and find somewhere else that may not contain any interference. Power cables is also another one to bear in mind, and they are often being laid down the middle of roads or pathways or even run through open fields these days. So if you do again get bad compass information, move your aircraft to a new location and try again. A poor or bad compass calibration is as bad as any of the two above, and again, as I mentioned earlier in the video, only calibrate it when you first get your aircraft, and don't calibrate it again unless you've been specifically told to do so. And even if DJI Go tells you to calibrate the compass, use a healthy level of suspicion that there could be something in the ground at that point. Move to another location, try it again, and if you continue to get warnings at that point, then recalibrate the compass. When you do calibrate it, make sure you do it outside, as far away from any metal as possible and as far away from any smart personal devices as you can. So Apple Watches, Android watches, your phones, leave them on the ground away from your aircraft when you do your calibration. And finally, if you are in an area of high magnetic intensity, so an area rich in iron or something like that, you could suddenly get compass errors, and again, I would try to shift takeoff location. The main thing to take away from compass is if you get any form of magnetic interference errors, land immediately. Do not ignore a compass error. The reality is it is one of the worst kind of errors you can get on your drone, and if you don't deal with it there and then, you are likely to end up in a far worse position when you take off. And that is the end of part 2 of this video. In part 3, we are going to be looking at GPS, satellites and HDOP and why it's important. Thank you very much for watching. Please subscribe to the channel.